Hello everyone, it's Benny, and in this video, with any luck, we're going to be implementing collision detection. But first, we have one very small thing we need to do. Very small, I promise. If I run, you notice we start outside the level. And that's not very good for collision detection, so I'm not going to do this very formally or do anything fancy at all. I'm literally just going to input various x and z coordinates until I actually end up in the level. Ooh, almost. I'll try 7, 7. And, okay, that appears to be working. So now I start off inside the level, meaning I should be able to do collision detection now. So, with that, let's go ahead and get started. Now, as you may know, as of video 31 in the 3D Game Engine series, we don't have any sort of physics engine or physics capabilities at all. So, in light of this, I'm going to be implementing my own in the level class. And I'm actually just going to create a method in here that I'll just call public, and it's going to be a vector 3 called check collisions. And you might be wondering, why is this returning a vector 3? And the reason is, what I'm going to sort of try and do is have this be a collision on a per-axis basis. So this will have a 1 where there's no collision, and 0 where there is an actual collision. And the end result of that is I can just multiply the collision vector with my movement vector, and then I get the final actual motion that I can perform. So it's a neat system of doing it, and I kind of like it. So, with that, let's take in the parameters. Let's see. First off, we need to know my old position, where I was before I made this movement, and I'm going to need to know vector 3f new position. So, just before and after. Where was I before I moved, and where am I now that I have moved? Nothing too fancy there. And let's see. You know, I can't think of anything else, so I'm just going to leave it at that for now. So, let's start off by creating a vector 2f that I'm going to call collision vector. And that's going to equal a new vector 2f, 1, 1. And now, yeah, this does return a vector 3f collision vector, but here's the thing. Our character is not moving up and down on the z-axis, so I'm only going to check collisions up and down on the y-axis. So I'm only going to check collisions on the x and z-axis, because, well, those are the only two places that a collision can ever possibly occur. That's why I'm using a vector 2f here. Now I'm also going to need a vector 3f movement vector, because, you know, it's all about motion. How did I move? And I'm just going to calculate this as new position dot subtract old position, and voila. So there. And now only if movement vector dot length is greater than 0 am I actually going to do anything. Otherwise, so basically all my big collision code is going to go in here. Otherwise, I'm just going to return a new vector 3f with collision vector dot get x, 1 for y. Well, since we shouldn't be moving in y in the first place, I'm going to go with 0 for y, and collision vector dot get y for the z component, because this is supposed to be an xz vector in world space. And that's pretty much just going to be all I'm going to do for now. That's going to be my check collision method. Now, I do have a slight problem in that I don't really have a good way of accessing this method from my actual player class. So, in order to actually, you know, access it from the player, what I'm going to do is I'm going to have my game class, I'm just going to have a public static void get level. And that's just going to return level. And I'm going to make level static. It's definitely not the best solution, but it's probably the easiest solution. Well, I guess I could make this static, but I really don't want to yet. And you may or may not find out in the future. But anyways, so I'm just going to have it like this for now. Again, not the best practice, but it's what's going to work for now. Anyways, now here's what I'm going to do. I'm my movement vector, oh good, it's already a field. So now that my movement vector is a field, what I actually want to do is I actually want to move this into the update method, because this isn't input stuff anymore, this is actual updating. And I'm going to do the same thing with move amount. Move amount is going to be right here, in the update method. And, oh okay, never mind. For some reason I thought I had an issue here, but I didn't for some reason. Anyways, now I'm actually going to do the collision detection. Of course, as you can see, it shouldn't do anything, but here's what I'm going to do. I'm going to have a vector 3f old position, which is just going to equal camera.getPass, and a vector 3f new position, which is going to equal old position dot add movement vector dot mul move amount. I think that should be right. So I'm just going to add on the new movement vector. Okay, cool. And now what I'm going to do is I'm going to have a vector 3f collision vector, which is going to equal game.getLevel dot check collisions with old position and new position. So now I know which axes I can move on. It's going to be 0 if I can't move, 1 if I can. And here's the cool thing about that. What I can do is I can just say movement vector equals movement vector dot mul collision vector. So the zeros will cancel the axes I actually can move in. Whoops. It helps I spell it right. So the zeros are just going to set whatever axes I can't move in to 0, and 1 is just going to keep whatever axes I can move in the same. And of course I'm not doing any collision detection right now, so this should actually do absolutely nothing. Good. That at least proves that I'm not doing anything yet, but still. So, excellent, that's exactly what I was hoping for. So, now let's go ahead and actually make our algorithm do something. So, here's where this whole sort of check collisions method is going to hinge around. And actually, this really shouldn't be above that. It should be about here. So, public void check collisions. And I'm also going to have a private void method, private vector 2f method. There we go. Called Rect Collide. And this is going to take in some old position, some vector, no, not 3f, 2f, old position, some new position, a vector 2f size 1, vector 2f size 2, and a vector 2f position 2. And this is sort of return null for the time being. And this is sort of going to be the way my collision system all sort of hinges upon. What this is going to do is, of course, going to take the old position and new position, and this is going to take the size of the object, whatever my player size is. Actually, come to think of it, that's probably a good thing to take in here, but I'll get to that in a moment. Going to take in the size of the upper object, in this case, the blocks. You know, the blocks actually make up the level. And the position of the other object, which of course, again, is the blocks. So it's going to treat the player and the blocks like rectangles. And it's going to see on which axes they intersect. If it's the x-axis, the y-axis, or the x and y-axis, using, of course, the old position and new position. And that way I can sort of determine, you know, which axes I'm colliding on. And that's useful because then I can just do some basic multiplication and figure out which movement on which axis is valid and which movement on which axis is not. Whew, that's a mouthful, but that's okay. So, I'm going to go ahead and take in some more parameters. So, what should I take in? Just floats? Yeah, I'm not going to do anything vector fancy here. Vector fancy, you know, you get the idea. Yeah, just going to take in some float object width and float object length. Because again, XZ plane. And I'm going to have a constant. So private, I can type static final. It's going to be, yeah, it's going to be a float called player size, which I'm going to set equal to 0.3f. I have no idea if that's going to work out or not, but we're going to find out. So take in player size and player size. Okay, cool. Now, what I'm going to do is I'm going to start creating my sort of initial vector 2s in here. If there actually can be a collision happening, I'm going to start setting up all my data to actually check that collision. So vector 2f block size. New vector 2f, which, let's see, what did I call the constants? Spot width and spot length. So spot width and spot length. Not a vector 2f, a vector 2f. Good lord, I can't type today. Vector 2f. Going to be object size, new vector 2f, of course, object width and object length. There we go. And a vector 2f of old position, good lord, old position 2, which is just going to equal my old position on x and z. So new vector 2f, old pos.getx, and old pos.getz. Come on. Fingers, work. Whew. Vector 2. New pos2 is a new vector 2f, new position.getx. You know, essentially I'm just casting everything to a vector 2. And this may have made you think of a certain thing that we did in GLSO, called swizzling, which would have made this whole process a lot easier. So let's pull out the notes and add a note. Well, actually we sort of have this somewhere already. Better vector math. I'll just add in here swizzling support. And now, let's go ahead and continue with this process. So here's what I'm going to do. For int I equals 0, I is less than level.getWidth, I plus plus. So I'm going to literally go through the whole level again. Not, I'm going to do j is less than level.getHeight, j plus plus. And what I'm going to do is I'm going to test if level.getPixel, actually in parentheses, level.getPixel sub I comma j, and 0xFF, so get the RGB components, is 0. So this is a solid wall. If this is the case, then we're going to check collision. And I'm not actually going to do anything fancy here. So what I'm going to do here is I'm just going to call, actually, it's going to be pretty easy. We can do collision vector equals collision vector dot mul by Rect Collide. And the reason, of course, this works is, again, the 0-1 canceling thing I keep talking about. So it's going to take in old pos, well, old pos 2, new pos 2. It's going to take in size 1. Size 1 should be the object size. Now, size 2, you have to be... Actually, wait. Something seems wrong here. Something seems very, very wrong here. Okay, never mind. I'm being an incomplete for some apparent reason. Okay. I don't know what... For some reason I thought that putting a block thing in here would be wrong, but it wouldn't at all. I don't know why I thought that. So block size, that's perfectly valid. Although now that I'm looking at it, it kind of makes more sense to me to have position 2 before vector 2f size 2. I don't know, call me crazy. So this is going to be the size, of course, the block size is going to be the size of block size, big surprise. As for the position though, what I'm going to do is I'm going to say block size dot mul by a new vector 2f I comma j. And what that's going to do, well, aside from giving me an error, what it's going to do, and aside from scrolling my screen where I don't want it to, what it's going to do, is it's going to take my I and j position, so essentially just where I am in the grid, and move that by block size. So essentially it's going to step over in block size increments I times, and step up in block size increments j times. And that's going to be very convenient in the fact that, well, not convenient, it's going to be very mathematic in the fact that it calculates where our block's final position is going to be. And with all that, finally, and did I mention finally, we can implement Rect Collide. Okay, so I'm going to start off with a vector2f result, new vector2f, and it's going to start as 0, 0. It's going to start off assuming that we've hit something on both axes. And the way the algorithm is going to work is I'm going to have two if statements, and they're going to see if we actually can move on these axes, if there's no possible way that we could have collided on this axis. And if that's the case, it's going to set it to 1 and move on. So, I'm going to start off with newPos.getX, my player's new position after moving. And I'm going to add size1.getWidth. So my player's, or getX. So my player's width. So essentially this is all the way at my player's right. If this is less than pos2.getX, because remember, I'm starting these boxes at the left. So this is my block's left edge. If my player's right edge is less than my block's left edge, there's no possible way that there could be a collision on the x-axis. They're not touching. So that's one possible condition. Now another possible condition is newPos.getX minus size1.getX. And in this case, it's going to be if it's, well, greater than my position 2's left edge, or my position 2's right edge. So if my player's left edge is greater than my object's right edge, damn it, if my player's left edge is greater than my position 2's right edge, yeah, I had it right. That's another possible collision case. And here's sort of how that works, because it's a little tricky to calculate. What I actually want is the actual physical x-coordinate, you know, like the I and j I have here. So what I actually want is, I'm going to start with my actual size, however big that is. So I'll just put S for size. Then I'm just going to add on to that I. I'll just put I, because, you know, it's at the I in here. So whatever its position is in the grid. Then what I'm going to do is I'm going to multiply this, so I'll just actually use the dot. I'm going to scale this by the size. And the idea here is, once I've gotten all the way over by the size, then, well, it will not only have the size of the object, well, you know, it'll scale this whole block, which represents how big it is by the size. That's the whole idea. And that should put it at the appropriate x position. Now here's the sort of cool thing about that. The way I'd calculate that is I have to calculate this I-coordinate, and then I have to divide that by size2.getX, and then I'd have to take that, I'd have to add size2.getX for the size, and then I'd have to scale the whole block up to be, well, in the appropriate position, because, you know, I have to scale it by size, don't I? Because there's going to be, you know, size number of blocks in between. That's why I'm scaling by size. That's how big all the blocks in between that distance are. Here's a really cool thing about that. Because I actually would have to calculate this, I can actually distribute this and just end up with position2.getX plus size 2x squared. That's really cool. So that's my way of calculating the right edge. So if my player's left edge is greater than right edge, again, not touching, can't possibly collide. And I'll also do the check for the old pos.getY. So I'm going to check on the y-axis. It's the same sort of check. In fact, I can copy and paste, actually. Well, I can always copy and paste. You'll see. So, except this time I want y. And I want old pos. So, and this is just to actually complete the rectangle. I've got new pos for x, and I'm only checking x, so I'm just going to use old pos for y. Actually, I wonder if you could get away with not doing this. I've never actually tried. I might try that after I get this working for you guys. So there we go. Doing same sort of in-out check on the y-axis. Now if any of these conditions are true, then result.setY x, not y, I'm doing check on the x-axis, 1. And for y, I have to do basically the same thing, except with new pass and old pass reversed. So, one moment. So I'm just going to, first off, set this to y, because I'm doing y check now. And just going to reverse old pass and new pass. If Java stops screwing up my tabs. There we go. So, and there we go. So now we've got old pass and new pass, and we're going to return the result. And with that, it should at least somewhat work. So if I go up against this wall, hey, we got collision detection. And if I go against this wall, I get stuck forever. And what this actually is because for some reason I forgot to change that this is new pass, don't know why. So now if I do that, I should have proper collision detection. And I should also be able to deal with something that's kind of been bothering me for a while now. I think our player moves way too fast, so I'm going to set this to 5. So now let's sort of explore the world. And that's way too slow, but whatever, it works. It gets the point across. And yeah, so I can explore the world. The player feels a little too far away when he's actually colliding, so I'm going to change this to 0.2f. See how that is? Yeah, that's better. It feels like I'm actually brushing up against it then. So there. And now the player's moving way too slow, so I'm going to change this to something like 8. I don't know. There we go. Not insane, not too slow, so yeah. And with that, we've got working collision detection. So excellent. And now, just because I'm curious, I don't think it will work, but it might. I'm going to comment this out. Copy. And, oh dear. Copy. And uncomment. And for this particular version of the equation, I'm just going to get rid of the old pass stuff. So, only going to check new pass in this version. Will it work? I don't think so, but I'm really curious to see if it actually does. Because, yeah, didn't think so. Okay, well, that was fun. We've got collision detection working. We can run around our level, we can't go through walls now, and it's excellent. So, hope you enjoyed, I hope you learned, and I will see you in the next video.